Okay, now let's look at what happens when I'm dealing with piecewise functions. So this tells us to use one-sided limits and then limit laws. So if you forgot what piecewise functions are, I recommend you go back and do a quick little review over them. You can just do a quick Google over them and you'll see a bunch of videos over it just to remind yourself. We learned this back in college algebra for what these look like. So if I were looking at the limit as x approaches -1 of f of x. So as x approaches -1, on the left-hand side, so for x values that are smaller than it, your function is approaching -4. If I look at what's happening as we're approaching -1 with numbers that are larger than it, we're going to be using this function. Because right after we leave -1, we're in the second function. So that's going to be, we will have, so that's going to be the limit as x approaches -1 from the right of x squared plus 2. So I can separate that out using limit laws. X squared and 2. And then for this first one, I can use the power rule, where this is going to be the same thing as the limit as x approaches -1 from the right-hand side of x, all squared, plus the limit as x approaches -1 from the right of 2. So basically your whole goal is to get it where you've got the limit of x or the limit of a number, and then you use those last couple properties. So now that I've got this limit as x approaches -1 of x, -1 of x, we can just plug in that -1. And then over here, when it's a constant, it's just 2. So I get -1 squared, which is 1. 1 plus 2 is 3. So because on the left-hand side and on the right-hand side I'm approaching different values, that means that the limit as x approaches -1 does not exist. Okay, let's see what happens as we're approaching 3. So let's look at this from both the right and the left-hand side. All right, so the limit as x approaches 3 from the left of that function is going to be equal to the limit as x approaches 3 from the left. So the numbers that are smaller than 3 are going to come from this piece, which comes from that function. So x squared plus 2. So that's going to give me the limit as x approaches 3 from the left of x squared plus the limit as x approaches 3 from the left of 2. So it's going to be doing the same thing we did on the other side for approaching -1 from the right. So I'm going to use that power rule and then plus the limit as x approaches 3 from the left of 2. So that's going to leave me with 3 squared plus 2, which is 11. Now, if I look at this from the other direction, the limit as x approaches 3 from the right-hand side of the function, so the values that are larger than 3 come from this piece, which is 4x minus 1. All right, so again, applying my limit laws, we can do the difference limit law to separate this out. So I'm going to get 4x minus the limit as x approaches 3 from the right of 1. So I'm going to use that constant to move that 4 in front so that I'm just left with the limit of x, or the limit of a constant. And that's going to give me 4 times 3 minus 1, which is, I'm running out of space. I'm going to have to do this sideways. Don't normally do this. Which gives me 11. So from the left, I approach 11. From the right, I approach 11. So that means the limit of the function, or as x approaches 3, is 11, not 3.